Hello everyone, I hope you all are doing great. Welcome you all to new series of Kubernetes where you are going to learn from beginner to advanced level. This course is going to give you in-depth learning path. This will have 10 projects as part of this complete series. You will be learning lot of different ways of setting up Kubernetes cluster. Now let us begin our course. So, very first thing, what you are going to learn on day one. In day one, you will be learning why Kubernetes. What is the need of Kubernetes? How Kubernetes made life easy for deploying applications and the complete architecture of Kubernetes. So, first question comes to our mind. Why Kubernetes? Kubernetes is a powerful container orchestration platform that gained widespread adoption in tech industry. There is a term here called orchestration. So what is this orchestration? Orchestration means you can automatically scale in or scale out. What is a scale in and a scale out? So suppose you have Flipkart Big Billion Sale, or suppose you have Amazon sale going on. Now, the normal customer volume to your application is 10,000 in a normal day. But when there is some sale, when there are lot of discounts given to the customers, lot of customers comes. Or suppose World Cup is going on, Cricket World Cup is going on. Right now, Hotstar will be having maybe 50 times more customer volume than the normal days. So now what this orchestration platform does, as per your requirement, on one click you can scale in your applications or scale out your applications. Means you can increase the capacity of your infrastructures by deploying multiple containers or multiple pods, and you can decrease it whenever needed. That's why this orchestration platform, which makes your life easy, in a click you can deploy, in a click you can decrease the size or you can increase the size. The second question comes, what is the benefit? Benefit is very clear. You can manage your applications as per your requirements. Now, using Kubernetes, it automates the deployment, scaling and management of containerized applications. It simplifies complex tasks associated with container orchestration, allowing developers and operators to focus on building and delivering applications. It makes portability easy. Portability easy means you can deploy your applications in any machines and you can carry it over any machine. So Kubernetes provide a consistent environment for deploying and running applications across different infrastructure environments. This portability is crucial for organizations adopting multi-cloud or hybrid cloud strategies. As I told, scalability. So with Kubernetes, applications can scale horizontally. Horizontally means adding more nodes to the cluster, like increasing it horizontal. There are two kind of scaling options, vertical and horizontal. Vertical means in a machine, suppose you have 2 CPU core and 8 GB of RAM. You can increase to 4 CPU core and 16 GB of RAM. That is called vertical scaling. But suppose in a cluster, you have 3 nodes. If you are adding 2 more nodes in the cluster, that is called horizontal scaling. So using Kubernetes, you can do horizontal scaling and add as much containers you want to add to the clusters. So this ensures optimal resource utilization and ability to handle varying workloads. As I told, example of big billion sales. Now, you can efficiently manage your resources. So whenever there is less load, you can decrease the size of clusters, you can decrease the number of pods, and if it's needed, you can increase it. You have the option of high availability, means Kubernetes support the deployment of applications in a highly available manner, distributing containers across nodes to prevent single point of failure. This enhances the reliability and availability of applications. It has the declarative configurations which I will be explaining deeper in coming lectures. You can do automated rollouts and rollbacks. Means in a single click your applications can be deployed and you can roll back your changes on single click. Now this is the most important. We all need to understand what is exactly Kubernetes architecture and what are different components. So being a developer, you can see this developer, they interact to API server. So Kubernetes have architecture where it has master nodes and worker nodes. Master node is mainly responsible for management work. Like it's a in a university, if you talk, there is a principal office or a college head office that controls all the different departments. So something similar like that. This Kubernetes master node controls all the different worker nodes. Worker nodes where actually your applications or pods are running. The master node contains API server. It has controllers. It has scheduler and it has a component called etcd. Etcd is a kind of database. Apart from that, the worker node contains components like kubelet, container runtime like Docker. They have the add-ons like DNS, UI and other stuff. Network proxy, that is Proxy and pod. So these are the different components which belongs to worker nodes. Now, what is the purpose of each component of master node, that I am going to explain. And then what are the different components of worker node, that I am going to explain. What is the benefit of this architecture, that also I am going to explain now. So first understand master node. So master node is responsible for managing the whole cluster. So master node is like head of department or head of whole cluster. Master is the head. Now it monitors the health checks of all nodes in the cluster. It stores the member information regarding the different nodes, planning which containers are scheduled to which worker nodes, monitoring the containers and nodes. So these are the different things which master node does. Suppose when a node failed, it moves the workload from failed node to another healthy worker node. So Kubernetes master is responsible for scheduling, provisioning, configuring and exposing API to the client. So all these are done by master node using component called as control plane components. So Kubernetes take care of service discovery, scaling, load balancing, self-healing, leader election, etc. Therefore, developers are no longer have to build these services inside of the applications. So Kubernetes take care of too many things. You can see it does the scaling, it do the service discovery, it does the load balancing, it does the self-healing, leader election. So all these kind of works is done by the Kubernetes master node. Now, there are four main components which is part of control plane, and control plane is nothing but master node. So it has a API server, it has scheduler, it has controller manager and etcd. First understand what is API server. So the API server is a centralized component where all the cluster components are communicated. Scheduler, controller manager and other worker node component communicate with the API server. Scheduler and controller manager request information to API server before taking any actions. This API server exposes the Kubernetes API. So you understood what is API server? API server is a centralized component where all the cluster components are communicated. So either the components like scheduler, controller manager or etcd, they all have to talk to the API server. And this API server even exposes the Kubernetes API, means somebody from the remote machine can use the Kubernetes API to interact to the Kubernetes cluster. Next component part of the master node is scheduler. So scheduler is responsible for assigning your applications to worker node. So this takes care of the job assignments or the pod assignment to the nodes. It will automatically detect which pod to place on which node based on the resource requirements, hardware constraints, and other factors. So scheduler doesn't blindly place the pod on the node. It's designed in such a smart way that it checks, okay, so I need to run a pod having 6 GB of RAM and 3 CPU core. So it will match all the different worker node, and which has enough resources, it will place only on that node. So it will smartly find out the optimum node which fulfills the requirement to run the application. Next component is controller manager. So the controller manager maintains the cluster. It handles node failures, replicating components, maintaining the correct number of pod. So this task is mainly done by controller manager. It constantly tries to keep system in desired state by comparing it with current state of systems. So controller mainly maintains the cluster. It handles the node failures, replication components, maintaining the correct number of pods. These all job is done by controller manager. And the last component is etcd. etcd is a data store that stores the cluster configuration. It is recommended that you have a backup as it is the source of truth of your cluster. So, and if anything happen, you can restore all the cluster components from this stored cluster configurations. etcd is a distributed, reliable key value store where all the configuration is stored in a documents and it is schema-less. So, etcd is a kind of database where in form of key value store all your different components are stored in etcd, and if something happens to your Kubernetes cluster, etcd can still help you to restore all the different components accordingly. Now worker node has three main components, and worker node is also called data plane. Master node is called control plane, and worker node is called data plane. So worker node has kubelet, proxy, and container runtime. So kubelet, proxy, and container runtime. Now let us see what is kubelet. So kubelet runs and manages the containers on node, and it talks to API server. The scheduler will update the spec. Now, what is kubelet? Kubelet runs on each worker node and it manages the container on the node, and its responsibility to talk to the API server. So you can tell in a college you have class representatives. So kubelet is like a class representative who talks to the department head or who talks to the college head and express the requirements or desires of the students. So similar like kubelet is a kind of representatives which runs and manages the containers on the node and talks to the API server. And node name with respective worker name, node name with respective worker node names, and kubelet controller will get a notification from API server, and it will then contact the container runtime like Docker, for example, to go out and pull images that requires to run the pod. So what exactly this means? That still Docker is used on those nodes because Docker is mainly handling the image part, like your application images. So this node name with respective worker node names and kubelet controller will get a notification from API server, and then it will contact the container runtime like Docker to go out and pull images that requires to run the pod. That's the purpose of kubelet. There is one more component deployed on each worker node that is called Qproxy. So the Qproxy does the load balancing traffic between application components. It is also called a service proxy which runs on each node in the Kubernetes cluster. It will constantly look for new services and appropriately create the rules on each node to forward traffic to services to backend pods respectively. So Qproxy is like a load balancing traffic component who takes care of the balancing of the traffic accordingly. And then you have container runtime. So container runtime, which runs the containers like Docker, Rocket, or Container D. Once you have a specification that describes your image for your application, the container runtime will pull the image and run the containers. So container runtime options is not only Docker. Instead of Docker, you can have Rocket or Container D installed on your servers, and they can take care of the container images, and they can pull the required image as per our requirements. And the most important object in whole Kubernetes, you will be listening the term that is called pod. So what is pod? Pods are the smallest unit of deployment in Kubernetes, as container is the smallest unit of deployment in Docker. So in Docker, we used to have container as the smallest deployment component, but in Kubernetes, you have pod as the smallest deployment component. Now, to understand it in an easy way, we can compare pods are nothing but a lightweight virtual machine in the virtualization world. Each pod consists of one or more containers. Pods are ephemeral in nature, as they come and go, and as the containers are stateless in nature, pods do not maintaining states. What do we mean by ephemeral? It means that pods, once destroyed, all the data is gone. It is not maintaining any state of your applications. So these pods need some mechanism to store your data. Those parts I am going to discuss in the later part of the video. Usually we run a single container inside a pod. So one container will run inside a pod. But there are some scenario where you run multiple containers inside a single pod, which are dependent on each other. Each time a pod spin up, they get a new IP address with virtual IP range assigned by the pod networking solutions. So each pod will get a new IP address whenever the pod comes up. And one more component, it is not part of your, mainly you need to install only on the worker nodes, but this can be kept at your local machines as well. So what is Qctl? Qctl is a command line utility, though, which can communicate or instruct the Kubernetes cluster to carry out certain tasks. With this, you can control the Kubernetes cluster manager. There are two ways we can instruct the API server to create, update, delete resources in Kubernetes cluster. The imperative way and the declarative way. If you are just getting started, then you can begin with imperative way, as I will be showing you in these videos, and slowly I will explain about the declarative ways as well. But in production, generally we use the declarative ways. So slowly I will be explaining about that part as well. So as you understood, Qctl is just a command line utility, and that help you to talk to the API server. That means Kubernetes cluster manager. You talk using the Qctl command, and you can perform any operations using this Qctl command. So that's it for today's lecture. In coming lectures, you'll be going to have lot of practical knowledge and lot of real-time industry level projects. Thank you so much guys for giving your valuable time.